In this demo, we will start replacing the calls to the in-memory data store with calls to the repository. Let's open the cities controller. And let's inject the repository instead of injecting the cities data store. Note that, as we learned before, we want to inject the contract and not the exact implementation. ICityInfo repository is defined in cityinfo.api.services, so let's import that namespace. And let's name the parameter cityinfo repository. We'll store it in a private read-only field, and as usual, we add a null check. And we can get rid of this cities data store field here. Alright, so far for that. Then let's have a look at returning all the cities. We can now call the getCitiesAsync method on our repository, which will provide us with a list of city entities. Important is that this call has to be awaited. getCitiesAsync returns a task of IEnumerable of entities.city. To get to the actual result, our list of city entities, we await this call. Because we await the call, we also have to make the getCities action on the controller async. This is important. For allowing asynchronous code to actually free up a thread when an I/O operation happens, async await has to be used from the outer layer all the way down to the innermost layer, typically the database layer. If you start at the innermost layer, as we did, the compiler really helps with this. It will block compiling if you use await in a non-async method. And with that, we've got our enumerable of city entities. These city entities are what our repository and context work on. However, they are not what the actions in our API should return. Those work on a different set of models, the DTOs. So we will need to map this list to a list of city DTO. But let's look at that city DTO again. It contains a list of points of interest and a count of those. We just chose not to include the points of interest this time. If we use this DTO, we would end up with an empty array of points of interest and a count of 0 in our results. That's not what we want. So let's add a new DTO. We'll name it City Without Points of Interest DTO. It has an ID, a name, and a description, but no collection of points of interest nor a total count of them. Once again, this is a very good reason to make the distinction between the entity model and the DTOs. Were we to return entity classes, we'd see an empty array. Alright, back to our cities controller. We can now state that we want to return an IEnumerable of city without points of interest DTO. And all we need to do next is map the city entities to city without points of interest DTOs. So we add a new variable, a list of city without points of interest DTO. And we run through our entities and map each entity to a new city without points of interest DTO object. Lastly, we return the results list. One thing left. Seeing this is now an async method, it obviously needs to return a task of action result of IEnumerable of city without points of interest DTO. Alright, so far for that. For now, let's comment out the code for getting a single city, as that won't work at this moment. Like that, we can at least test our getCities method. Let's give that a try. We've got a request to get our cities lined up here. Let's send that request. And there we go. We get back our 3 cities, this time coming from the database. What you also notice is that they are nicely ordered by name and no longer by ID. Back to our code. We've got mapping code here to map a city entity to a city DTO. Code like that is typically quite error prone. Just imagine this for an object with 20 properties, of which 5 are collections on types that again have tens of properties. And once we start manipulating objects, we'll have even more mapping code. From the DTO that's inputted to the entity, and then from the entity back to the DTO. Luckily, there's a solution for this. A proven and tested mapping tool. And I guess some of you will have heard of it already. AutoMapper.